Topic for chapter 1 is gravity. So the definition of gravity is the force of attractions between objects that is due to their masses. So essentially, gravity is the attraction between the center of two objects. So the center of one object is being pulled towards the center of the other. So all objects are experiencing an attraction towards all other objects. No matter how big or small, there is some force of gravity between every single object, whether it's you and the earth, you and your laptop right now, you and the car. There's some source of gravity that is happening. Most objects we have, you can't sense that gravity because the gravity is so small. The bigger the object, the more the gravity there is. So the one object that we ever sense a gravity with is Earth. Earth is enormous. Earth has a big enough gravity that it pulls every object on its surface towards the center of it. That's why we are pulled towards the surface of the Earth, because we are being pulled towards the center. So even though we have really big objects out there like whales and planes and ships, they're nowhere near the size of the Earth. They have a bigger gravity than you do, but the Earth is the only thing big enough that we actually experience it. So there is a very minuscule gravitational attraction between you and a book that you're reading, but it's not enough that you're ever going to sense. The only thing we have that we experience typically is the Earth, and that's going to pull us towards its center. Always stays the same because Earth's mass is staying the same. So, like I said, it's pulling everything towards the center of the Earth, and the person who discovered this was Isaac Newton. He made the law of universal gravitation, which said that that gravity is moving at a constant rate. We have in the past decade or so updated the number slightly, but it used to be just 9.8 meters per second squared. Now we are working with 9.81 meters per second squared. We are now, we know it's a little more exact than that. So you need to remember that number. We will use gravity a lot in our calculations. So you have to know that gravity is a 9.81 meters per second squared. So the law of universal gravitation also says that the smaller the objects, the smaller gravitational force. So like we said, the Earth is really big, so it has a very big gravity that we can sense. If you go to different planets, the bigger the planet, the more the gravity. So some place like Jupiter, which is a lot bigger than Earth, has a very strong gravitational pull, whereas Pluto would have a smaller gravitational pull than Earth. Also, the closer the objects are, the more gravity there's going to be. So if you have the reason that we have moons that that orbit our Earth, we have one moon in our case. Some planets have multiple, is because that is close enough to the Earth that it is caught in its gravity. If we got far enough away from Earth, so if you went into space, eventually you would get too far away and you wouldn't have enough gravitational pull to pull you back down. So that is that's why if you go into space, you get away from that gravitational pull, because the farther away you are, the smaller the gravitational force there is. So one thing with gravity, which is something we have talked about when we talked about chemistry, is weight, and that is the measure of the gravitational force exerted on an object. So remember, this is something that will change if you go to a different planet. You go to a bigger planet like Mars, you have more of a weight. You go to a smaller planet, it's going to be less of a weight. But we measure this in newtons. That is the unit that we will use. And I'm not sure why I don't have this written on the slideshow. So I want you to write this down somewhere next to this section, and I will give you extra credit for writing this because this is important to have. But and again, forgive my writing here, but the equation for weight is taking your mass and then taking that times the gravity of that planet. If I can make it G, that would be awesome. So mass times gravity. So we'll calculate with Earth a lot, so we'll have 9.81, but it's just going to depend on, I'll tell you what the gravity is, or I'll tell you what planet we're on. So make sure you write that down. And just again, the kind of a recap of what we talked about. Mass is the amount of matter that an object has. It will not change no matter where you are in the universe, but weight will change because it's the effect that gravity has on that mass. So depending on the gravity of the location you're at, that's going to affect the weight.